This video is going to carry on from the part 1 video, and we're going to continue looking at the LAN-Caster engine test demo game. The difference between this part 2 and the part 1 is that this part 2, there's not just data created in tiled, whether it be map or tile set data. It's also requiring code. So all of these tests demonstrate some feature of the game engine or test some feature of the game engine, but they also require some code. So there's going to be some trigger mechanics added. There's going to be some extending some mechanics. There's going to be some using of text and things like that that require some code. So this is a very good place to look for how to do some of these things when there's a code aspect to it. So again, just starting from last time, I'm just going to do a quick review. If we look at the launcher for the engine test, so I'm in the LAN-Caster base directory, we see that we're going to do the start server, and the game is called engineTest. We're running at 60 frames a second just to make it a little harder during testing. We're in test mode with verbose logging turned on, and we have one client that we add to the engineTest game. So I'm going to go ahead and run that launcher. Run engineTest. Okay, and there we are. So I'm going to skip through all the things that we did for the first video on the part 1 video. So I'm just going to press S3. Again, we're running in test mode here. So F3 will move me forward map by map. Okay, and this is our first thing. So this is a test of the collisions between the anchor of the player sprite and some particular triggers, and then they have some basic action. Now, just a very quick review of what we're about to see so you understand it. When we have our player sprite, so in here we've got our person, we know the XY of the top corner, we know the width, and we know the height of that tile. But we also have an aspect called an anchor. So right somewhere around that feet, there will be the anchor X, anchor Y. And this is the point we actually are concerned about. None of the rest of this is going to be considered. We really only care about that anchor point. And what we care about is when does it overlap something on the trigger layer. And this is our basic setup. So what we want to have is as this point moves into a trigger, the trigger it's inside will get called. If that anchor moves inside more than one trigger will be called. So that's the basic setup of what we're about to try to do and test. And what we want to do is have a display here of a number 1 show up if we're inside the trigger 1, a 3 for the trigger 3, a 2 for trigger 2, and then all of them if we're in the overlap area where they all overlap. So let's open up the map data for this, and maybe I will close all the rest of these. Discard that. Okay, so let me open up the layer test, because we always want to start with the layer that we have set up, and open up the map. All right, so this is what we're looking at for a map. Now, just to talk about the 1, 2, and 3 that appear, what they are is layers. So they're just, I'm going to turn them off one at a time. So I'm just changing the visibility. So that's all that is on those layers. And then we also have our static text, which of course is just information. So we don't really need to worry about that one. I'm just going to leave it off for a minute. And then we also have some buttons down here. So this is just a graying out area, just so that we can see that, because you have to remember that normally the triggers aren't visible. So if we didn't have that, this is what our map would look like. So that's what we're going to see on our map, and the triggers is invisible to the game. So if I go back here, you can see the slight graying of that area, and you can see the other layers appearing. So how do we make this work? Because we want to have the collision occur. So we have the triggers. I'm just going to look at one of these rectangles, but you can see that each of these rectangles overlap in the middle. So I would look at one of these rectangles. This rectangle is of type layer show. Now this is not part of the map engine. This is something we're going to add on. So it's of type layer show, and the layer name is layer 1. Well, this right here is layer 1. So that's layer 1. So this trigger rectangle that we have on the trigger layer is going to reference layer 1 as a property, and it's of type layer show. So we want to make it so that when the player anchor is inside that the one layer is visible, and the rest of the time it is not visible. So let's go figure out how to do that. So inside engineTest, I'm going to open up maps and look at trigger layers and look at the server.py. So this is a subclass of server map. And so it's engine server map, that's what we're subclassing. Now, normally in a game, you would subclass the game server map, and the game server map would subclass the engine server map. This is a server map inside an actual map, and we're subclassing all the way back to the engine. That's just because the engineTest game doesn't even have a subclass for server map at the game level. So if you don't understand that, that's okay. Just know that we are subclassing server map from the engine. So we want to add a layer show mechanic. So we need to create a function that will be called when the layer is started. When the step is started, as well as when the trigger is fired. So at the start of every step, we actually want to make sure that everything is hidden. So when we start a step, 60 times a second, I actually want to start by hiding all these. And then I want to turn on the ones that are visible. So at the beginning of every step, I hide them all. And in this case, I turn on the 1. In this case, I hide them all, and then I turn on 1, 2, 3. And I'm doing that 60 times a second. Okay, so that layer visibility change is actually happening 60 times a second. So if you watch the video on the server step mechanism, you'll know at the beginning of every step, functions that start with the name step map start, they will be called. So I have a step map start and then my mechanic name, layer show. And what I'm saying here is I am saying find for every object of type layer show on the triggers layer, and don't just return the first one, return them all. And you can go read in the engine map.py, you can go read how find object works. But this is going to return a list of all of the objects on the triggers layer of type layer show, and there's 3 of them. Right, so if we go back and look, there's 1, 2, 3. Those are our 3 rectangles on the trigger layers, all of type layer show, each one with a different layer name property. So what's going to happen is it's going to return all 3. We're going to make sure that that trigger that's returned has a layer name property. And again, they appear as prop layer name, okay, when they are ingested from the tile data into LAN-Caster. So the layer name here will actually show up inside the trigger object as prop layer name, just like that. And basically we're saying if it's not there, then there's a problem. And we're going to log that problem, and that'll come out the console. Otherwise, if it is there, we're going to set the layer visibility of that named layer. Okay, so that's going to be layer 1, layer 2, or layer 3 to false. So we're going to turn it off. You can go read all about the layer visibility code. It's in the engine map.py. So set that layer by name and set it to false, which means it's hidden. Okay, so now all 3 of our layers are hidden. Now, as the step moves on, right, so we're doing this every 60th of a second, so we've hidden them all. If the player sprite, or any sprite for that matter, is inside any of those triggers, it will turn on. So this function will get called with the name of the trigger, the trigger object and the sprite object that triggered it. So we're just going to make sure that layer name is again in the trigger object. And if it is, we're going to set layer visibility of that trigger object to true. So this says to me that any sprite could do this. So in fact, I haven't tried this, but I think I will right now. Let me go back all the way back to our holdable test. So what I'll do is I'm going to go up here. I'm going to go pick up the crossbow. Okay, so I'm actually holding the crossbow. I'll make this window a little bigger so you can see it. So let's try to fire off that trigger. So I can walk into this and that will fire off the trigger. But if I drop the crossbow and walk out, that trigger is still firing. So now the crossbow, because its anchor point is inside that trigger, is firing. Now if I go here, I can get 1 and 3, I get 1, 2, or I can get them all. I can pick up that, move it into the middle, drop it. So what we're seeing is that the crossbow's on the sprite layer, so is our player, and either one of them can trigger these triggers. So that's a basic test of multiple triggers being fired and being fired by multiple objects. And that's happening again multiple times a second. It's happening every step. And this mechanic has to work on a per step basis. You can't kind of do things that happen over multiple steps. Or if you do, you have to store data about that. I mean, this mechanic stores no data. Every step is isolated. It doesn't know anything about previous steps. Okay, so that's the basics of the trigger and lit layer visibility test. So let's move on. The next one here is a test that shows you all the different ways you can display text in LAN-Caster. And there's several different built-in ways. You can extend and add your own. You can change the fonts and all those sorts of things. The demo game is actually a great way to know how to do the fonts. I'm just going to check and make sure that is good. Okay. So this is just the bare minimum built-in text types. So the first one is speech text. We can make text appear above the player. And some of these are player specific, and some of them could apply to any sprite, any objects on the sprite layer. So speech text can apply to anything on the sprite layer. In the demo, you'll actually see that the chickens occasionally talk. The next one is label. So you'll notice that underneath Bob, it just changed to Jane, and now it just changed back to Bob. The next one here is action text. So this is actually causing text to appear at the bottom of the screen in the action text area. And the final one is Marquee Text. I'm going to turn Marquee Text on, and I can turn Marquee Text off. And in fact, Marquee Text isn't map specific. If I jump to another map, you'll see the Marquee Text actually stays. If I go back, I can turn it back off. So let's look how this is implemented. So I'm going to open up this map. So let's go to map 14. Oops. Open the wrong thing there. Map 14. Okay. So what we have, again, I'm going to turn off some of the things. I'll turn off the static text, and I'll turn off the graphic layer. What we end up with is a trigger layer with several rectangles. And all of these rectangles are a new custom trigger type, and the custom trigger type is called add text. And each of these triggers has got two things. It has the text to add and the text type. Again, this is not a particularly useful game mechanic I've added, this add text game mechanic. It's just used for testing, but I will show you how it works so you can understand each one. Oh, and we also have a trigger of a different type called remove marquee text. So let's just make sure we have add text, add text, add text, add text. I'm just looking up here at the trigger type and add text, and all of those have a text and a text type property. And then I have one that is of type remove marquee text. So if I go look at the server map in here, so if I go into the test 14 trigger text and I open up server.py, I will see trigger add text. So that is going to get called anytime there's a collision between something on the sprite layer and the trigger rectangle. And I have something called trigger remove marquee text. With the trigger add text, if there's a collision between a sprite and the trigger, it's going to first check to make sure that the trigger has the correct property. So it needs a text property and a text type property. Again, that prop dash gets added. And assuming it has those, then we're good to go. We basically say if the trigger text type is speech, action, label, or marquee, then I make the appropriate calls to add that kind of text. Now, some of these texts will only last one step. In other words, things like speech text, you have to re-add them every every step. So you can see right here's a note, speech text is removed at the start of every step. So we have to re-add that one every single step. The same is true of action text. but label text actually lasts forever, and as does marquee text until they're actually changed again or removed. So if I go back here and look, I can see that that speech text, it will go away when I leave the trigger. The action text, it's there, but once I leave the trigger, it's removed. That's because it's removed every single step, and if I don't add it back in with my mechanic, it will stop appearing. However, things like changing my name to Bob or changing my name to Jane, once I leave the trigger, it sticks. That doesn't change. The same is true for marquee text. If I leave that, marquee text lasts until which point it is actually removed. Okay, so I have to enter the remove one. If I go look at the remove marquee text trigger, it simply calls del remove marquee text. All right. The other thing again that we can do, just to show that this is not specific to a player, I can go there. I can take the crossbow, drop it on top of speech text, and we see now the crossbow is talking. So probably not the smartest thing. I mean, from a game design, you probably, when you write your game mechanic, you want to say, you know, if this is not a player, or if this is not of type, you know, if this sprite is not of type player, then it probably doesn't talk. But in fact, in the demo, the chickens talk. And I think if I do this, will it give label text to the crossbow? Yeah, it gives. So this, I mean, there's no checking of any kind. And I will get, that's a good point. Action text is player specific. So I've dropped the crossbow on top of action text, but action text only applies to a player. It only makes sense because it's something the player can interact with. So it doesn't make sense for it to apply to anything but a player. The same is true for marquee text. So if I remove the marquee text, it removes it from me. So the two on the right are player specific. The two on the left, speech text and label text, are not. Anything could have those. All right. Anything else to say about text? You can look at the demo for how to change text, fonts, and all that kind of stuff. I won't go into that here, but each of these types of text that appear, you can custom set their font and all sorts of things like that. Okay, so let's move on. Okay, so PortKey. So this is an extension of a map door, actually. So what did I want is in Harry Potter, if you've read those books, there's an object called a PortKey that when you touch it, it transports you someplace. So here I'm walking up to something, and I'm getting this available action, touch jar with one handle, press spacebar, and it transports me. Here it says touch jar with two handles, press spacebar, it transports me. So let's look at how this one works. So let's start by opening up the map for it. So maps, this is map 15 PortKey. Okay, so again, let's turn off the static text. It doesn't actually impact it. And let's turn off the graphics just because it doesn't impact anything. So we end up with two layers here. We end up with the sprites, which have our jars on them. And we end up with the reference layer, which has 2 points. Now, we essentially want these to work kind of like a map door. So in some ways, they're the same as a map door. So the reference points here, there's nothing particularly special. They're just a point with a name. And because they're a point, they have an XY coordinate. So this is simply how we're going to figure out where to land the player. So most of the magic here is happening inside these sprites. So these sprites are of type PortKey. So we're going to write a game mechanic called PortKey. And each of these have a name. So you see jar with 2 handles and jar with 1 handle. And they each have a destination reference, just like a map door has, which is the name of one of these other objects that's on the reference layer. Okay, so destination reference is an object on the reference layer. All right, so that's the setup. Not a lot of complexity there. So let's look at the code and what it does. So if we go look inside PortKey, and this is really a test of extending some particular mechanics. I won't get into what we're actually testing here in detail. I'll more show how to do this. So again, we are subclassing engine map, just like we've done the last 2 times. And we have 2 methods for our PortKey mechanic. We have the init method, and we have the trigger PortKey. Now, you'll see right in here, trigger map door. The trigger PortKey is not going to do the work itself. It's actually going to pass it through to map door. So a little bit tricky there. So what the magic here is more in the init part. What we're going to do, and we've seen this in other places as well, is we're actually going to take that PortKey sprite. So we're going to find object. Now by default, find object looks in the sprite layer. So we're going to look for all things on the sprite layer that are of type PortKey, and we're going to return a list of them. And for each one of them, we're going to copy them, change their collision type. Again, this is kind of a pattern you can follow, but I won't go into all the details. This is heavily explained actually in the Holdable mechanic. So if you want to understand the pattern of how to take a sprite, turn it into a trigger while still being a sprite, this is what's here, but it's actually very well explained in the Holdable mechanic. And maybe I'll actually just pop that up just as a reminder. So under under LAN-Caster source engine server map, if we look inside the Holdable mechanic, there is a function called add holdable trigger, and that documents what we're doing with the code that we're looking at there, and it gives you all the blown out. But I mean, if you summarize it, I lost my file that I was looking at. PortKey. If I summarize it, these are the only statements. It's not particularly complicated, but there is a few things there. So this is making sure that those PortKeys are also triggers, or makes a copy of the PortKey that is a trigger that follows the PortKey around if the PortKey were to move. Okay, and then the trigger mechanic is very simple. So there's two things that happen. So when the player collides with the trigger that we've created, trigger PortKey will happen. And what'll happen is we'll get the PortKey object, that's the trigger, okay, and the sprite. And essentially, if the user's requesting an action, we're going to move them. But let's assume the player just walks up. So if I just walk up here, oh, I'm actually holding a crossbow. Let me drop my crossbow. So if I walk up to this, it's saying available action, touch jar with one handle. So if the user's requested an action, so if there's an action in the sprite being requested, then do this. There's not. I'm just standing there. So what it's going to do is going to set my action text. And remember from the previous example, I said the action test only lasts one step. So if I were to walk out of the trigger, the action text were to vanish. So I'm inside it. Now this is convenient because I know that that's going to keep getting triggered every step. So the next step, if I do come in and the action text is there, it's going to consume the action. So we don't want multiple things using the action. So we're saying, okay, I want to use that action. And then we're going to trigger map door. So all we're doing is we're passing through the PortKey and the sprite to the trigger map door as if it is a map door. Now, we just happen to, when we designed this, use this custom property called destination reference, which is the exact same name that a map door would use. So in this way, we're able to extend map door. So we just call that, and map door will do its thing, which we've already talked about in the previous video, and transport us. So that is how we've done that. So boop, and we can get transported. Here, the name of it is jar with two handles, and you can see that right here, right? The PortKey's name, right? So jar with two handles, that's the PortKey's name, because that's the object on the, trigger layer now, because I copied it to the trigger layer. Press spacebar, and we're transported to the other reference point. All right. I don't think this does anything. Yeah, carrying something makes no difference. Yeah, it'll still work. Okay. On to the next one. So this one's an interesting one. With this map, you'll notice I just carried a crossbow onto this map from the previous map. If I drop that crossbow, a countdown timer appears. Now, this is very different than the last few mechanics in that there is data that changes over time, over multiple steps. So there's 60 steps a second here, and there's 5 seconds. And any holdable that you drop on this map is going to be removed from the game. So that's all there is to it. This map is extremely simple. Let me open it up. So maps. This is the timer map. So again, I'll get rid of the static text. So all this is a sprite layer, and on that sprite layer are 3 tile objects that have type holdable. Now they also have names. The only reason they have names is when you pick them up, it'll say action, pickup, jug, pickup, key, pickup. So that's just part of the holdable mechanic. So what we're seeing here is nothing new as far as an identified mechanic. So what's going on? How is something new happening when this is just a holdable? What we've done is we've extended holdable. We've actually added to that mechanic. So if I go look at the server map for this one, so this is the delete holdable after mechanic. It's a terrible name for a mechanic and not very inventive. But effectively, it is not going to make a new mechanic. It's extending. So there is a function. If you go look at the code for holdable, and one of the reasons I went into so much of the code in the previous video about those mechanics that you can just use, why do you know the code for them at all? It's because you might want to extend them. That's why it's worth looking at them. And here's an example of extending it. So we did all of that new functionality with just 2 functions. The first one is we extended the drop holdable. So drop holdable, if you go read the code in source engine server map.py and look for the holdable code, you will read about what it's trying to do. So this is going to actually call the super in the middle of the function. So I'm going to call because I've subclassed it, I'm extending it. So to start with, I'm going to get a copy of the thing the sprite is holding. So I'm just going to get a copy of that variable. Then I'm going to let the super class actually do what it's supposed to do, which is drop that. So that's going to drop that holdable onto the map. Then what I'm going to do is, and this is a bit trickier, I'm going to get any followers for that holdable. So the followers in this case are the triggers. So if you look at how a holdable is made, actually it's a tile object on the sprite layer, but it also has a trigger object on the trigger layer. So I need to get its followers, and then for each follower, I'm going to add a del after. So I'm adding a parameter, and this is really the key of it here. And I'm doing whatever the time is right now. This is how to get the current time. Okay. And you have to do that, you have to make sure that you import engine time. Then you can call the time functions. So this is whatever the current time is plus 5 seconds. And I'm just adding this parameter called del after into follower. Okay, sorry, I just need a sip of water. Okay, I know I didn't do a lot of explaining how these followers work. If you want more details, just ask a question on GitHub if you don't understand that code or you haven't already explored that. Okay, so step map start del holdable after. Crazy name, but what it means, if you read this, this is actually a step function. So this drop holdable is a extension of any time that we drop holdable, this will be called, but this function is going to be called every single step. So step map start del holdable. So at the start of every step on the map, this function will be called. There's no useful parameters. So what we're going to do is we're going to search for triggers. So for every trigger on the trigger layer, if holdable sprite is in the trigger and del after is in the trigger. So if we look back up, when we got the holdable, we found its followers. Now the things that follow it are going to be those triggers. So those followers, we've added that del after. So if the holdable sprite's in the trigger and the del after is in the trigger, and I mean, you really have to go read the holdable code to understand this holdable sprite part, because it's doing that part in its own code. But if those are both there, then if the del after timer is less than the current time, we are going to remove the follower and then remove the remove the holdable object from the sprite layer from all layers, and then remove the trigger from all layers. We could actually specifically remove those from each individual layer, but using all layers is fine as well. And that's what removes it. Now, what about the countdown? So for every trigger, if the triggerable meets our criteria, so if it has a holdable sprite in it and it has a del after in it, but the timer hasn't gone off yet, then I'm going to set the label text for it. So I'm going to set the label text of the sprite. So from the trigger, it's got a link back to the sprite. And I'm going to set it to the time that I'm supposed to vanish minus the current time, and that's going to be a fraction of seconds, so it might be like 4.8 seconds. I'm going to take the ceiling of that and convert it to a string. So that's what's happening there. And that's it. So that's how it happens. So I should spend just a second here because I have been dancing around this follower issue for a minute here. So let me go here and just talk through what I was talking about. So when we have something on the sprite layer, so let's say it's a bottle and it's a holdable. We also have a trigger for that. And that trigger has a link back to the sprite. Now, if you were to move the sprite, change its XY, the trigger would also automatically move. The engine takes care of that because it's set to follow. So this guy right here is what we call follow. Now, the code for the holdable goes further and actually stores a specific link to the holdable as well. But just so you understand, that's what's happening there. So this way that when someone triggers it, they're going to trigger here on the trigger for the holdable, but it doesn't collide directly with the sprite. Anyways, that might not make a lot of sense. I apologize. I know it's a little distorted, but hopefully you get the general idea of what's happening, and you can go look in the code a little more deeply to figure out the rest. Okay. This one's again, a very simple map. So this one is just showing you what's in a dictionary for a sprite. So as I'm moving around, you can see the move entry there. You can see the label text is there, the height, width, direction. So anytime I'm moving, the direction is being set. And I showed in the last video picking up a crossbow. So this is just a neat test just to show. I mean, there's nothing specific being tested here, but I will just show you the map and code very quickly. So if we go back to maps and we go into the map itself, there's very, very little on this. So if I get rid of the tile layer, that will hide that graphic, which doesn't actually do anything. The text, it doesn't do anything. And I'm basically left with two things. I'm left with a trigger. And this trigger, if I can select it properly, there we go. So this is a trigger of type talk, very, very simple. And I have a sprite here, which is a crossbow, and that's just of type holdable. And then the code on this layer, there is one thing very new. If I go in here and I go look at the server map, there's a mechanic in here called trigger talk. And basically it just says, if it's a sprite player and it has the correct what to say, so if we go look at that again, if we go look at that trigger, it's got a what to say. I can see stars. So if we go here and we check out the, we see I can see stars. And you can actually see it up here in the text as well, speech text. I can see stars. It's been added to the Sprite's dictionary. So, I mean, I won't go into the details of that you should know, you should be able to work your way through that code now as to how that works. But that's all there is in the server map. Okay, and we saw what was on the map. So what the heck is drawing all of this text up here? You know, where is it being done? So this class also has client map. So, or sorry, this map has subclass client map. And in this client map, we have extended the blit tile object from client map. And basically what we're saying here is if the object about to be drawn is a player, so if it's of type player, then we're going to create a text object, and then we're going to render this text object. And then we're going to call super blit tile to actually do the work of drawing it. Because if we don't have the super call here, our little guy would never be drawn. So, but this is the code that says, hey, I see this is the player, so I'm going to draw some text. And we create the text object. So this is a text object that is the same format as a tiled text object, and we're just making it in code, and then we're passing it to blit text object. And you can go check the JSON. So, I mean, if you were to look at the JSON for the map, actually the one we're on, we can see that there is there's a text object right there in JSON. And you can see that it's going to have a very similar format to the one that we're doing in code. So we're making up our own, and then we're just rendering it by passing it to the blit text object. So not very fancy, pretty straightforward, but we are setting some text sizes and things. Again, if you don't set default text sizes, you can specifically set it on every text object before you pass it into blit text object. But again, that's something you would do in code. Okay, so that's how that little works. I mean, certainly have a look at this, play with it, understand what's in there. You know, with this one being a tile object, you see both of its global tile ID, something that we talked about in the in a couple videos way back, talking about maps and tile sets. And you can also see its tile set name and tile set number, which are quite different. The global tile ID for this map, and then the tile ID in its tile set. Now, the tile ID in the tile set as before doesn't change, but the global tile ID is map centric, so it might change map to map, and the LAN-Caster engine takes care of that for you. Okay, so most of the other things here are what I'm going to call advanced tests, and I'm going to show them without going into much detail, but I'll just talk about how each one basically works, and you can go off and explore the maps and the code yourself. So the first one here is a slide. So this one, what it is, it's a trigger, or it's a whole bunch of triggers, and those triggers set the linear direction of the player, and it kind of takes any linear movement they have already and forces them down the slide. So you can go look at that and how that's structured by opening the map file and the server map.py. This one's actually a very advanced test as far as collisions go. So all the blocks here are sprites, and these blocks you can actually push around. So pushing is something that's a little interesting. And I'm just going to push this. See, I can push this one into another one. And this is the point where, oops, I didn't get it actually through the map door. Because I'm on the sprite layer and so is the block, I can push the block through the map door. Now, just an interesting thing to hear about collisions. There'll be another video specifically on collisions, but that check location function that we talked about before, every time something moves, it has to be moved to a valid location. I just put a block on top of the map door, and this block has collision type rectangle. Now, you've never seen anything before on the sprite layer that's anything but a point collision. So because of this, I can't go through the map door anymore. So I actually have to go over here, push the block off the destination, and then I can go through the map door. So the next test here, anyways, this one's quite complicated as far as the code goes, but it is something you can have a look at if you want to explore it. This is exactly the same test. I'm just going to use the right mouse button to jump, except this one's now recursive. So this allows for recursive block pushing. So if I just take this and start pushing blocks, as you can see, I can start pushing blocks and blocks and blocks. Besides that, same test. The code is significantly more complicated because there is some recursion involved. This is a test that ironically, and if you watch the little guys there, they just got turned into skulls. This is a test of really most of the geometry library. And what you're seeing here is a little bit of a ray trace code, but and you can open the file yourself, but what it's using is under LAN-Caster source engine geometry. It's trying to test all of the functionality in here. And there's actually quite a bit of geometry and math functions in here. So it's trying to exercise this. That's what the actual test is. But what we're actually implementing here is array beam and reflectors. So again, I'm not going to go into this test, but you're welcome to explore the code, ask questions. And maybe there'll be a video specifically on this later on. Another test here. So all the motion that you've seen to date has been linear motion. So set speed in a straight line with the potential of sliding. That's the move linear mechanic you've seen so far. This is a new mechanic, and it actually has something follow a polygon. Now, if you're doing this in a game, you might want to use this type of mechanic to have a monster follow a path. I might suggest that you put the path on the reference layer, not on the sprite layer, because if it was on the reference layer, you wouldn't see the path, you would just see the monster moving. But this is just a basic idea. You can have a look at the code for that test. Again, the test I'm talking about is always in the bottom right corner. That's the map folder you can go look in. This is another one. This is Orbital Motion. So this is another move test. So things orbiting one another, and also supporting collisions with the rectangles and things. This one's add follower. Now, we've talked about followers in terms of something on the trigger layer following a sprite moving on the sprite layer. This is actually a test of that system, of the ability to have one thing follow another thing. It doesn't have to be a trigger and a sprite. It could be other things. It could be sprites and sprites. So if I move into this box here, a trigger is going to add all these other 3 sprites as followers to my player. And now I'm moving. And if I go over here, it's going to remove my followers. If I come back over here, it's going to add those followers back on with their relative positions, as you can see. So that's just something that plays with that. Make sure it works correctly. You can check the code out for that. The final one here is a bit of a silly test. Oh, I brought my followers with me. So this one's a bit of a test just on performance, making sure that the server can handle a lot of moving sprites. When you get into this many sprites, you'll definitely start to have performance things. I don't know how many are here. I haven't actually counted them, but it's a bunch, and they're all in motion. They're all trying to follow the player with a very poor follow algorithm, which is by design, because I just wanted them all moving in a bit of different directions and overlapping. When something like this is running, though, you can actually go back here to the server, and you can actually see that, our server is 3% busy, 2% busy, 1% busy. If I just play this for a little while, because that gets output, I think, every minute. If I just play this for a little while, we'll see that the server is going to be much more busy during the minute that this map is being active. Again, maps don't run unless at least one player is on the map. So maps that have nothing on them, their game logic's not going to run. Okay, there we go. Now we see that the game engine, the server, is actually 27% busy. So if you had multiple players, so I mean, you could have as many players as you want on this map, that would be fine. But if you had, say, 5 maps like this with 5 players each on a map like this, then your server would run out. It would be more than 100% busy, and it would start to slow down. But it's really, I mean, you can have as many players as you want on this map. It's really how many maps you have simultaneously running with this kind of load. Okay, that's the end of the advanced test. For interesting, I will actually just hit Control-C here. One of the things that you get output if you do Control-C the server is you can see how many milliseconds it's taking each map to do its step. So we're trying to do 60 times a second. So that mini sprites test was taking 3.29 milliseconds. You see most of the other maps are taking almost no time at all. So much more intense. Anything under 5 milliseconds, you're generally fine. Keep in mind, we're also trying to run at 60 frames per second or 60 steps per second with this engine test. Normally 30 is enough, or even 15. So lots of headroom there. All right. Thanks very much.